All right, here we go with iChem Lesson 5, Anatomy on the Periodic Table. This is our first of 3 iChem lessons that you will find within this unit. Make sure you have your viewing guide with the periodic table on the back. Having the properly annotated periodic table with the list of things at the bottom of your viewing guide is part of your grade for completing this iChem lesson, so make sure that's done. Before we do that, though, let's do a quick history lesson. You read about this, but I want to cover the main points. First, you read about Dmitri Mendeleev, considered the father of the periodic table. You need to know that he arranged the elements in order of increasing atomic mass, which as a whole is pretty much a continuing trend of the periodic table that we have today. However, it is actually organized, done so by Henry Moseley, by increasing atomic number. Sometimes these go hand in hand, but there's some atomic mass anomalies that don't fit the atomic number trend. A few more definitions before we move on. First, periodic law. Many of the physical and chemical properties of the elements tend to reoccur in a systematic manner with increasing atomic number. So it means sort of repeat the same set of properties periodically. They also fall into 3 major classifications: metals, nonmetals, and what's called metalloids. Make sure you have this definition down. If you need to pause it, do so. I'm moving on. Okay, so the properties of metals first. Typically solid at room temperature, conduct electricity and heat. They tend to be shiny, malleable, which is like if you banged it with a hammer, you could dent it. Ductile is sort of bendable. And they lose electrons to be stable. We'll talk more about this last one tomorrow. Non-metal properties. They're diverse in room temperature state of matter, which means some are solid, some are liquid, and some are gas. There are very few liquids at room temperature on the periodic table. In fact, just 2 elements exist as liquid when they're not bonded to something else at room temperature. They do not conduct electricity very well. They're brittle, so as opposed to being able to bend it, if you bended a solid non-metal, it would probably break. They're not lustrous, which is sort of the opposite of shiny. And they tend to gain electrons to become stable. That other one, that metalloid that we're going to look at in the periodic table, they can have properties of each, meaning they could be shiny but not conducting, or ductile and not conducting, and so on. So let's kind of flip over and annotate the periodic table, locating the metals, nonmetal, and metalloid. The very first thing you need to draw is this zigzag line. Here, starting at boron, goes under, down, over, down, over, down, over, down. Notice also that this darkened line continues up, if we follow up and over, to be under hydrogen. Okay? Everything to the left of this line is a metal. Everything to the right of the line is a nonmetal, with the exception of the ones touching the line, the ones that are highlighted in blue. So maybe you want to kind of get out a highlighter, circle these, and color code it somehow so that you know that these ones here are metalloids. All of them that are touching this zigzag line except for Al and Po. The other things I want to add to this periodic table are the 6 important groups. We'll talk more tomorrow about the idea of groups and periods, but a group is a column on the periodic table. It's also sometimes called a family. Okay, so this first column, not including hydrogen, is called alkali metals. So somehow color code, label, note on your periodic table that this first column, except for hydrogen, is called alkali metals. Next column, you have alkaline earth metals. This block in the middle, so basically your D block, is considered to be transition metals. So where you have your D block, you have what's called transition metals. The second to last column is called halogens. And the last column, as we know, is called noble gases. The one we don't really talk too much about, way down here, is called inner transition metals. Remember, transition metals are this block, and technically, this whole piece here belongs right up there in the periodic table. Sometimes you might see an extended version with that long, skinny piece stuck in the middle. One other thing I want you to notice is on the top of the periodic table I have them labeled with Roman numerals. Those numbers match the A groups. So 1A, 2A, 3A, 4A, over to 8. These are how we're going to call the groups by number. So group 1 is alkali metals. Group 2, alkaline earth metals. Group 3, 4, 5, and 6 don't have a special name, really. We call them families by who comes first. So this would be the boron family. This would be the carbon family. This would be the nitrogen family. And this would be the oxygen family. You don't have to draw that on there, but it's some terminology we're going to start using in class. You do need to know these 6 specific groups, though, because they're not really named in a way that immediately pinpoints them to somewhere on the periodic table. If you need a little bit more time annotating, pause here, take it. Remember, you're going to have, as part of your homework grade, this needs to be done. To be prepared to use this and build on it tomorrow, we need to do 2 more definitions. The first one is valence electrons. Maybe you've heard this word come up. You've seen it in us talking about the orbital diagrams or the electron configurations. This is the electrons in the outer shell of an atom. Okay, so if we're drawing our Bohr diagram, these are all of the electrons that would show up on the outer circle. These are important because these are the ones involved in forming bonds to adjacent atoms. So we need to understand our electron configuration diagrams, how to use them to understand valence electrons, and then once we understand that, next unit we'll start talking about how these bond based on, in part, the idea of this octet rule. It's a chemical rule of thumb, which atoms a main group element, so those 1 through 8A groups tend to combine or arrange in such a way that each atom has 8 electrons in its valence shell. So everybody wants to have 8, essentially, giving it the same electron configuration of a noble gas. Noble gases, if you notice, will all have 8 in that outer shell, that outer circle of their electron configuration, with the exception, obviously, of helium, because helium only has 2 electrons. Its outer shell is that 1s only, and that can only fit 2. All right, so make sure you have all the definitions, your periodic table annotated with the metals, nonmetals, metalloids, and your special groups. We will add the other 2 bits shown in your notes tomorrow.